The absolute value of a real number is a tool which measures the magnitude of the real number, the size of it. For example, if I look at the absolute value of -2, we write that in these vertical bars, and it returns the value of 2 because 2 is the size, the positive amount of that number -2, ignoring the sign. Graphically, it tells you how far away that value of -2 is from 0 on the real number line, its magnitude. The distance from here to there is 2 units. If I want to be formal here and define the absolute value of x, I really need to think about two cases, which we indicate in this somewhat cumbersome bracket notation here. So I've written a curly brace, and I'm going to list the rules required to compute the absolute value of x. The first rule is that the absolute value of x is x itself if x is greater than or equal to 0. The second rule is I take the opposite value of x, minus x, if x is strictly less than 0. So this brace here is just a way of breaking down the formula for computing absolute value into the necessary cases. I read on the right-hand side what condition is true about my number, and then I apply the formula appropriate for my value of x. Let's illustrate that with a couple of examples. If I want the absolute value of 7, 7 is greater than or equal to 0, so the absolute value of 7 is 7 itself. I don't change the value. If I want the absolute value of -7, -7 is less than 0. The formula here says take its opposite value. So I'm going to put a minus sign in front of the number -7. Negative of -7. The two minus signs cancel out, and I get 7 as expected from the absolute value. I'm going to take the absolute value of 0. 0 is equal to 0 here. The equality says that I just return the value of 0 itself. The absolute value of 0 is 0. And that makes sense because 0 is 0 units away from 0. The absolute value is useful for measuring distance between 2 points on the real number line. So for example, if I have a number x and a number y, and I want to measure how far apart they are in the real number line, what I will do is just subtract those two values. The distance between x and y is x minus y. The only problem with subtraction is I might have subtracted in the wrong order, and I got a negative amount. And since I want distance, I'm going to take the absolute value of x minus y to get that magnitude of the quantity. Let's illustrate this. The distance between, say, -3 and 4, I get by just subtracting them. And I'm just going to subtract them in the order that I see them, -3 minus 4. I may have or may not have subtracted in the right order, so I'm going to take absolute value just to make the result positive. And in fact, I did subtract in the wrong order. -7 is what the difference is, but the absolute value takes care of that, gives me 7. And in fact, if x is equal to -3 on the left and y is equal to 4 on the right, and I measure that distance between them, it is 7 units from there to there. We commonly need to simplify expressions that have absolute values in them. And since the value of the absolute value depends on whether or not the input to that expression is positive or negative, you typically have to do some case-by-case analysis to decide how this expression will simplify. Let's look at this example. I want us to simplify the absolute value of x divided by x itself. Notice that this expression is not sensible. It's undefined if x is 0 because I'd be asking you to divide by 0. So I'm asking us only to simplify for x not equal to 0. There are going to be two cases. The first case is when the x inside the absolute value is positive. So let's assume that x is positive. Then the absolute value of x over x simplifies. How does it simplify? Well, because x is positive, the absolute value doesn't change the expression. This is just x over itself. And so I'm taking x over x, which gives me 1. If x is less than 0, then the quantity inside the absolute values is now negative, and I have to change its sign, so it's going to require a different approach here. The absolute value of x over x is in fact the opposite of x over x. Notice how I have to change the sign of my input x, in this case, because I am working with a negative number. That number in the numerator is now positive, and the ratio of these two expressions will have different signs, and the ratio will be -1. So in conclusion, we see that the value of this expression, absolute value of x over x, is going to depend on whether or not our value of x is positive or negative. We can summarize that with a curly brace. In the first case, we got 1, and that was true if x was greater than 0. In the second case, we got -1, and that was true if x was less than 0. And as we discussed, this expression is undefined. In other words, it has no value if x itself is equal to 0.